Hey guys, how you doing? So today I want to talk to you about continuity. I promise you it is one of the most straight up concepts in calculus, okay? The name pretty much just says that something is continuous. Let me show you what that means. So let's suppose we have a graph, okay? We have f of x and this is its graph. We don't care how we define it. Let's just say this is simply the curve it will follow. So now I want you to think, what does it mean that something is continuous? Well, we know something continuous means that it doesn't break. It is something that is consistent because it is following a defined path. And it is something that, you could say that connects two things, right? It means that it doesn't break, okay? It is an unbroken path. This is an unbroken path. There are no undefined values because its path is defined. There is like no gaps, when we have piecewise functions. Sometimes we're going like to a value in y, and then we go to a value smaller because then we switch to a different piece. We switch a different condition. In piecewise functions we have gaps. We have maybe sometimes jumps, you could call it like that. In this case we don't have no jumps, we don't have no gaps, we don't have any of that, okay? This is continuous. Now, how do we define something continuous mathematically? Well, what we do is we say, I'm going to call this point A, okay? Let's say that is A. If the limit as x approaches A from the right, so from values bigger than A would be this way. So if we approach A from this, and it is the same as if we approach, it is the same as the limit as we approach A from the left. These are lateral limits, remember. And those two things are also the same as the function evaluated at that A point. This is what we call, this is something continuous, okay? Continuous. Do you write continuous like that? I hope you like continuous like that. English is not my first language, so well, I hope that's correct. So this is continuity, okay? Something that doesn't break, and mathematically we define it like this. When we have a limit as we approach A from the right, and it is the same limit as we approach A from the left, and it is also the same value as f of A, because, well, here we have f of A is f of A. In this case, well, it would be 5. F of A equals 5. Okay, that also means that these two limits also, approach 5, or well, not approach 5, but equals 5, okay? So, if we have two limits, and they come from different sides, they get to the same value, and also the function evaluated at that same value equals those two limits from the two different sides. This is continuous, okay? And we say this is continuous at x equals A, okay? You can say a function is continuous at this point, or you could say a function is generally continuous because it doesn't have any break, or any gap or any undefined values. For example, if I give you the function f of x equals 2x. Well, we know this function is generally continuous in every point because you're never gonna get an undefined value, and also in any A value you pick, well, you're gonna fulfill this condition. The limit as you approach, and this would give like a line like this, right? And now if you approach, let's say this is A, and now if you approach A from this side, well, you're gonna get, let's say this is A, right? And this should be f of A. If you approach A from the right side, well, you're gonna get f of A, okay? And that's the condition we want. And if you approach A from the left side, well, you're also gonna get f of A, okay? That is what we define as continuous, okay? Something that doesn't break, and if we approach from both sides and the value we get there equals the function evaluated at that point, that is continuity, okay? Now I want to show you some things that you might encounter sometimes, some black dots, some empty dots. I want to show you that. So now, what are some dots like this or some empty circles that you may have seen before? Well, it's pretty simple. Now, let's say we have the function that we had before, but now there is these two things. Now, I want to ask you something. Is this function continuous at a? Well, if you know what these two things are, hopefully you've seen that before, this means that when we approach a, or f of a in this case, does not equal 5, okay? In this case, there is an empty circle, or there is an undefined value or point, you could say, which is here. In this case, when we get to a, f of a will be up here, okay? That is why it is empty, and then the line or the continuous path that it will follow should be up here, okay? This is what we define now as f of a, okay? So now f of a would be 6. Now, is this continuous? Well, now let's see it. So let's say, what is the limit as x approaches a from the right side? Well, if we come from the right side, we're gonna get to 5. This is equal to 5. And now if we come from the left side, well, that is also equal to the limit as we approach a from the right side, okay? So now, oh, I missed the f of x. Well, that's awful notation. Yeah, there should be an f of x right here. F of x equals, yeah, I hope you guys see it. So now, I want to ask you something. Is this continuous? Remember, something continuous, the two lateral limits are equal to each other, but also equal to the function evaluated at that point. Now, is the function f of a, does f of a equal 5? No, we know it equals 6. So that means that these two things, unfortunately, they are not the same as f of a, because f of a in this case is 6, not 5, and these limits are equal to 5, okay? This is not continuous. In this case, when we have a function like this with a gap in here, so, in this case, we could say that this is a piecewise function. And when, let's say we have, I don't know, just like an algebraic expression. And we say this will happen when x is equal, so in that exact point, when x is equal to a, right? And when it is equal to a, well, we're going to do a different operation. And that will get us to 6 and not 5, okay? This is not continuous. When you see a dot that is away from the line of a graph, it will very likely be discontinuous, okay? This is what we call discontinuous. So in this case, we could say that f of x is discontinuous at x equals a. Pretty simple, because when we approach a from both sides, yes, we get the same value, but f of a does not equal the same value, okay? You need 3 things so that a function is continuous at a. The lateral limits must be the same, but you also need f of a to be the same as those 2 limits, okay? This is discontinuity. I hope you guys enjoyed the video and learned something today. See you in the next one.